On a Friday morning in July, the world's most valuable company lost its crown. Nvidia slipped and briefly handed the most valuable company spot to Apple. Taiwan Semiconductor, fresh off a 77% jump in quarterly profit, fell 7%. SoftBank, Wall Street's favorite proxy for OpenAI, dropped 9%. The trigger wasn't a war, a tariff, or a bad earnings call. It was an AI model released by a 3-year-old startup in Beijing. This is Kimi K3, the largest open-weight AI model ever released. And in the next 12 minutes, I'll show you exactly what's inside it and why it rattled $500 billion worth of markets. Moonshot AI was founded in Beijing in 2023, back when Chinese AI was still treated as a punchline in Silicon Valley. By 2024, Alibaba had put $1 billion into the company, at a $2.5 billion valuation. In July 2025, Moonshot released Kimi K2, a 1 trillion parameter model, and crucially, the weights were open. Its successors, K2.5 and K2.6, quietly became the budget coding models of choice for developers, including plenty inside Silicon Valley. And on July 16th, 2026, Moonshot dropped Kimi K3. Today, mid-funding round, Moonshot is valued at roughly $31.5 billion. That's a 12x markup in 2 years. One thing to be precise about, open-weight means you can download the model's parameters and run it yourself. The training data and code stays private. The API is live right now. The full weights go public on July 27th. Kimi K3 has 2.8 trillion parameters. A parameter is just a number the model learned during training, a tiny knob. K3 has 2.8 trillion knobs, each tuned over and over against most of the written internet. That makes K3 nearly 3 times the size of the last year's K2, and the largest AI model anyone has ever put on the open internet. The American Frontier Labs almost certainly run models in this class, but you cannot download theirs. In 10 days, you'll be able to download this one. But here's the twist. K3 never actually uses all 2.8 trillion parameters at once, and that twist is the whole ballgame. K3 is what's called a mixture of experts model, MOE for short. Instead of one giant monolithic network, picture 896 smaller specialist networks. The experts. Every time a token comes in, a small routing network picks just 16 of those experts to handle it. 16 out of 896. That's under 2% of the model doing the work at any given moment. In practice, that works out to roughly 50 billion active parameters per token. So K3 stores the knowledge of a 2.8 trillion parameter brain, but pays the electricity bill of 50 billion parameter one. Moonshot calls its version of this recipe stable latent MOE, and it's half the story of why K3 is so cheap to run. The other half is the attention trick. K3 can read up to 1 million tokens in a single prompt. This is roughly 10 novels held in mind at once. There's a reason long context is hard, and it's the transformer's defining habit, attention. In a standard transformer, every token compares itself to every other token in the context. Double the text and you quadruple the comparisons. At 1 million tokens, that quadratic bill becomes absurd. K3's answer is Kimi Delta Attention, KDA. It's a linear attention mechanism refined from a design called gated DeltaNet. Instead of comparing everything to everything, KDA keeps a compressed running memory that updates as the model reads. But pure linear attention forgets things, so K3 hedges. 3 out of every 4 layers use cheap KDA. And every 4th layer keeps exact full attention, a periodic reality check. The payoff is enormous, up to 75% less memory spent on the cache that holds your context, and up to 6.3 times faster generation at million token lengths. There's one more ingredient, and it's the mysterious one, something Moonshot calls attention residuals. The claim: layers can selectively reach back to earlier representations, making training about 25% more efficient for under 2% extra compute. Worth knowing, there's no paper on it yet. Right now it's a name, a claim, and a promised technical report. We will see. Okay, so it's big and it's clever. Is it actually good? Independent evaluator Artificial Analysis scores K3 at 76 on its coding index, 57 on intelligence, and 51 on agentic tasks. On LM Arena, where real users vote blind on model outputs, K3 debuted at number 1 on front-end code arena at 1679 ELO. On the main text leaderboard, it sits at 1486, right in frontier territory. Across 6 major coding benchmarks, it placed top 3 in every single one, and first in SWE Marathon and Program Bench. On Terminal Bench 2.1, it scored 80.9, half a point behind OpenAI's GPT 5.6 Sol, the closed model leader. Moonshot's own claim goes further, competitive with Anthropic's Fable 5 and quote, substantially outperforming Opus 4.8 and GPT 5.6 Sol. Grain of salt, these are day 1 numbers and some are self-reported. Leaderboards always move once the launch high fades. But even the independent numbers alone say something remarkable. An open model is now trading blows with a closed frontier. Now the part that actually moved markets, not the benchmarks, the invoice. K3 costs $3 per million input tokens, 3 cents if that input is cached, and $15 per million output tokens. Compare that to Anthropic's Fable 5, arguably the strongest model on the market, at $50 per million output tokens. That's a frontier class output at less than a third of the price. One industry newsletter summed it up in a sentence: Opus class intelligence at Sonnet pricing. And this pricing isn't charity, and it isn't a loss leader. It falls straight out of the architecture. Sparse experts mean less compute per token. KDA means less memory per user. Cheap to run becomes cheap to sell. Now that's the DeepSeek playbook, executed a year later at 4 times the scale. Quick reality check before you clear space on your hard drive. Open weights do not mean it runs on your laptop. 2.80 trillion parameters, even squeezed down to 8 bits each, is nearly 3 terabytes of weights. You'd need a full rack of GPUs just to hold that in memory. This is a model for clouds and companies, not gaming PCs. But that's exactly the audience Moonshot wants. Every cloud provider on Earth can now serve a frontier class model without licensing one from a US lab. And within weeks of weights landing, expect the community to ship quantized and distilled versions that run on far less. To understand why markets reacted the way they did, rewind to January 2025. A Chinese lab called DeepSeek released R1 and briefly wiped $600 billion of Nvidia in a single day. Markets learned a reflex that day. Cheap Chinese AI means sell American compute. So when K3 landed, the reflex fired again. Nvidia down, TSMC down 7, SoftBank down 9. Axios ran the headline, China just erased America's AI lead. Is that true? On raw capability, the US labs probably still hold an edge behind closed doors. But remember, Washington has spent 4 years trying to keep top-end chips out of China. K3 was trained under those restrictions. The constraints did not stop the model, they saved it. Nearly every trick in K3 exists to squeeze more intelligence out of less compute. And when the weights land, every company on Earth can run, fine-tune and study a frontier scale model for free. And that's the real story here. Not that China caught up on a leaderboard, but that the frontier itself is becoming a free download. 3 things to watch from here. Number 1, the technical report. Does attention residuals hold up once researchers can actually read how it works? Number 2, the leaderboards. Day 1 LO always drifts once the launch crowd stops voting. Where K3 settles in a month matters more than where it debuted. And number 3, the response. OpenAI, Anthropic and Google now have a $15 problem, and the next pricing pages will tell you how seriously they take it. The weights drop July 27th, 10 days from now. Anyone on Earth can see what a frontier model is made of. If this was useful, subscribe. And thanks for watching.